of Cambridge exams from the 2022 and 2023 papers. Okay, so let's start with the first question. A student makes a circuit to switch on a 6-watt lamp from two different switches X and Y. Shows the circuit. Switch X is in position P. State the position of switch Y for the lamp to be lit. Okay, for the lamp to function, we need a closed circuit. That circuit should be in a loop. Let me draw it for you. It should be like, if there is a positive terminal, there is a negative terminal, there is a lamp, and this circuit should be complete like this. So the current can start from one point and can easily pass from one point to the other end of the battery. Okay, so this is the precondition. So let's see in which form the circuit can be completed. So as shown in the figure, the switch X is attached with P. So let's suppose the current start flowing from the point, from the positive side of the battery. It will travel this way, it will pass through the circuit, and this pass through, and it will reach at this point, and then at this point. Now there are two possible positions. The switch can be attached with R and can be attached with S. If this switch is attached with S, the current will flow this way, and there is a dead end at Q, so there is no way to flow, so the current will stop there. So this is not a right, this is not a right way, this is not a right combination for the current to flow. So the right option is the current should move from at R, it will move this way, and there is already a connection between them, and this will provide a complete loop. So R is the right option. So switch should be, so let me draw it here. It should be at point, it should be at this point, and it will be disconnected with this position. So the current will start flowing from positive terminal, it will reach this point, pass through the battery all the way, move there, moves through this, there, and it reach there. So it will complete a pass. So switch Y, switch Y needs to complete circuit. So option is R. Okay, in part B, the current in the lamp is 0.50 ampere when the potential difference across the lamp is 6 watts. This is the potential difference. We have to calculate the resistance. Okay, so let's write down the given data. We have a current is I, that is equals to 0.50 ampere. This is, we have a potential difference, this is equals to V, that is 6.0 V. We have to find resistance, that is basically R. We have to use Ohm's law. Ohm's law is V is equals to IR, as R is needed. So what we have to do, this I will go on the left side, so the equation will become V divided by I is equals to R. So now let's put the value. R is equals to V value we have, this is 6, and for I we have 0 0.5. 6 divided by 0 0.5 give you 12, and the units are ohms. So answer is 12 ohm resistance. Moving toward the next question is the same question, and part C, the student connect another 6-watt lamp in a parallel with the first lamp as shown figure 9.2. Give two advantages of connecting the lamp in parallel. Okay, so when the lamps are connected in parallel, so let's analyze it. The current will start moving from this point, and it will have two paths to flow. It can flow from this point, and it will flow from this point as well. Okay, in parallel combination, both the lamps will have the same potential difference. So one advantage is both lamps both lamps will have same potential difference. Okay, the second advantage is, let's suppose if this connection is detached, let's suppose this is detached from this point, so still if the current start from there, it it will not flow this way, but it can flow this way. So this will be on and this will be off. So even if one connection is breakdown, the other will still work. So this is the benefit of using a parallel circuit. So the second is, one if one lamp fail, other will still work. Okay, so this is the advantage. Let's move toward the second question. A student investigate the electrical resistance of some components, shows an incomplete diagram of the circuit used by the student. What we have to do, state the term used for the component Y. So this is component Y. This is basically a diagram for thermistor. This is thermistor. Okay, so you need to memorize the electrical circuit symbols. Second part, as the student uses the circuit to measure the resistance of the component Y. Complete the diagram by adding electrical symbol to show an ammeter and a voltmeter correctly connected to the determine the resistance of the component Y. Okay, so some points you need to keep in mind. This is not an answer, just a note to remember. Ammeter is always installed in series. Okay, it is always installed in series with the component in which you want to measure current, and voltmeter is always parallel with it, parallel with component basically. Okay, so where is the component? Component is this. Why is the component? So we have to draw a ammeter. So if I want to draw an ammeter in series, so this will be ammeter, symbol A. So the Y and ammeter are in series, and if I have to draw a voltmeter in parallel, so these are the two terminals of the component Y, so I have to attach the voltmeter with these. It can be attached this way or it can be attached this way. Both are right. Okay, so stick with one option. You can draw any one of them. Okay, so this is the diagram. You don't need to write down this is just for your help. Question 2b shows two resistances A and B. Resistor A and resistor B are connected in series. You have to state the combined resistance. Okay, so you have to remember the formula for the combined resistance. Combined resistance is in series. It's simply added up, RA plus RB plus RC. That was formula. And for the parallel, we have a relation 1 over R total combined, that is 1 over RA plus 1 over RB plus 1 over RC. So as both are in series as given, so it is simply RA plus RB. RA is 5, RB is 7. That will give you 12 ohm. Okay, so that is the answer. In the second part, resistance A and resistor B are connected in parallel. Compare the combined resistance when the when in parallel with the resistance of resistor A alone. Okay, if you calculate the combined resistance of this 5 and 7 as a whole, so the answer will always be less than the resistance of the individual component. Okay, the answer will be, if you see one is 7, one is 5, the lowest value is 5, so your answer of a parallel combination will be less than 5 always. You can check it if you want to by applying a simple relation. 1 over 5 plus 1 over 7 is equals to 1 over RT. You can find it by solving it, the value of RT. It will always be less than 5. Okay, so you just need to remember, it will be, the answer will be for this question is combined resistance will be smaller than A. A was 5. Okay, it was the least value of the resistance, individual resistance. Okay, so, and there is a note for you to remember. Note is that combined resistance, note down on your notebook for the future reference, combined resistance of resistors in parallel is smaller than the resistance of one resistor alone. Okay, it is applicable for all the cases when they are attached in parallel. Okay, let's move toward the next question. 3a shows a circuit for determining the resistance of a component. What we have to do, we have to label the fixed resistor by a symbol R. So this is a ammeter, this is a voltmeter, and this is a fixed resistor. So you have to write down R there. Okay, in the B part, two components in figure 10.1 measure electrical quantities. You have to identify both the components. So M, this symbol is for the current, ammeter. Ammeter means the current. Its units are A, ampere. V, it means the potential difference. Potential difference, that is voltage. Symbol is V of the units. Okay, watts. So let's move toward the next part of this question. 3c, a student uses the circuit in 10.1 to determine the resistance of wire made from the same material. State how the resistance of a wire is related to its length and its diameter. Okay, for you, it's a note for again this topic. You have to keep in mind that resistance is directly proportional to the length. If you increase the length, resistance will increase, and resistance is inversely proportional to the area. Okay, but in this question they are asking you about the diameter. Okay, so if we consider the diameter, we know that area of a circular wire will be pi r square, or we know that r is basically d by 2, so it can be pi d square divided by 4. So we are not going into so much detail. We just can write down for this question that increasing length increase resistance, and increasing diameter decrease resistance. Okay, if you state that resistance is directly proportional, inversely proportional to the diameter, so that will be a wrong statement. Why? Because it's inversely proportional to the square of the diameter. Okay, because when you put the value here of this area, it will give you a d square. Okay, So we are not going into that much detail. We can just write down that increasing length increase resistance and increasing diameter will decrease the resistance. That is enough. Question 4a, 9.1 and figure 9.2 each shows an electrical circuit. Each circuit has two lamps connected to an electrical supply. State the term used to describe each electrical circuit. Write the term uses for the circuit. Okay, this circuit is the first one. This is parallel. Achha, how we know this is parallel? Because if you see, these are the two terminals with which this X is attached, with these the Y is attached, and with these this power source is also attached. So all the components are attached with the common terminals. So this type is called parallel. The other one is series. Why this is series? Because they are attached in a line, in a row. This is the one end of the lamp, and where one is ending, it's the starting point of second, and there's other end and there is a power supply end. So this is called end to end, and this we can say face to face in a parallel combination. Okay, and this is for the okay. So the answer is series and parallel. In question 4b, state two disadvantage of the circuit in figure 9.2. So 9.2 disadvantages are, let's suppose if for some reason the circuit is, the wire of the circuit is breakdown from any point for any reason. Let's suppose it is disconnected from this point. So the whole circuit will be dysfunctional. Both the lamps will not function. Okay, so this is a disadvantage. And if it's working, the both the lamps will be working. So one disadvantage is if one is stop working, the both the lamps will be stop working. And the second disadvantage is we don't have any control over the individual lamps. We can't do that. We can switch on one lamp and the second is switch off. It's not possible. Either both of the lamps will be switch on or both of the lamp will be switch off. So the disadvantages are, the first one is lamps are less bright. One disadvantage is this. Why? Because they're attached in series. The total voltage, this is the total voltage provided, will be divided among both of them. Okay, so V is equals to V1 plus V2. So they will have a less voltage, so their brightness will be less. Lamps are less bright. Second is if one lamp breaks, the other does not work. Okay, and third, two are enough, but third can be lamps cannot be switched independently. Okay, this is the for the series circuit disadvantages. Question 4c, redraw the circuit in 9.1 with switch that will turn lamp X and Y on and off independently of each other. This was the diagram for 9.1. We have to redraw this diagram with the switches to control X and Y. Okay, so let's draw it again. There we have, this is a power supply, there was a lamp, you can draw a switch here, and there is a second lamp, you can draw another switch here. Okay, so this is a diagram. This is S1, this is S2. S is the switch, S1 is switch 1 and S2 is switch 2. Okay, so in the next And we have to show as well that with switches that will turn lamp X on and off into acha. We have to draw two more diagrams in which we will show that we can control them independently. So with the next diagram, with when S1 is on and S2 is off. On mean close, off mean open. So this diagram will be like one is on, so this will be a complete circuit, this will be open. Okay, so this is S2, there was a S1, so the only lamp, this lamp will be lit. Okay, and the second is when S1 is off, off mean open, and S2 is on mean close for the circuit. And this is the power supply, this is open, this is a lamp 1, this is switch 2 that is closed, S2, this is S1. Okay, so if you want to see the functioning of current will flow from this point and it will be move like this, so this will only work. And for this, the current will flow from this and this will only work. Okay, moving to the next question, shows another circuit. The lamp can be turned on and off using two different switches S1 and S2. Complete the table stating when the lamps are on or off. The first one has been done for you. Okay, what is first one? Switch S1 is on K position and S2 is at C position. So S1 is so what is the precondition? Precondition is current need a closed path, a complete loop to flow. So let's suppose in the given scenario, if the current start from this point, it will come here and it will go there and there is no path to flow. Okay, so this will be off, that is given. So we have to apply the same rule. So let's suppose, let's do it for the other scenarios. For the second part, what we have, S1 is attached with K and S2 is attached with W. So this is same and this will be not here, this will be attached with this thing. So current will start moving from this point, it will flow from this point, it will move there, it will move there. Okay, so it is move from towards the next side, so it will be on. Okay, so the next scenario is when first one is with J and the second is with K. So it's mean it is attached there with J, not there, and with this is with W there. Okay, not there. So let's see for the current start flowing from this point, it will come this way, go there, and there is no path to flow, so it will be off. Okay, because that is a dead end. So let's discuss for the J and Z. So for J, it will be there, this is the connection, and for Z, Z is already done, so it's the C. So let's discuss the currents. Current start from this point, it will move there, go there, down, and there's a path available and current will flow, so it is on. Okay, and next question 5a shows the symbol for electrical components. You have to write down its name, it's a repetition, it's a thermistor that is shown in the diagram. Okay, in question 5b, the temperature of the component is shown. What we have to do, use the graph to determine the resistance of the component at a temperature 10 Celsius. Okay, so where is 10 Celsius? Y-axis is showing temperature. You have to tell its resistance, so it's 2000. Okay, and units are also given, it's 2000 ohms. In the next part, at another temperature, the resistance of the resistor is 800 ohms. Calculate the current in the component when the connected with a 12 watt supply. So let's write down the data. What we have a resistance that is 800. We have voltage that is 12.0 watts. We have to find current. Ohm's law is V is equals to IR. Excuse me. And I is equals to V divided by R. So value of V is 12 and value of R is 800. So 12 divided by 800 will give you 0.015 and units are ampere. Okay, let's move toward the next question. The student who built the circuit in part A want to change it so that it becomes sensitive to light rather than heat. So state the change the student should make. Okay, heat sensitive. For heat we use thermistor. Okay, thermistor is a heat dependent resistor, and for light we use LDR. LDR stands for light dependent resistor. So if you simply want to change its sensitivity from heat to light, you have to replace thermistor with LDR. So answer is replace thermistor with light dependent resistor. Okay. 5T. Draw the symbol for the replacement component you suggested. Okay, so you have to draw a component of thermistor. So thermistor is, sorry, for the LDR. LDR is a light dependent resistor. So this is a sign of resistor, and these arrows are representing a light. So this is LDR, light dependent resistor.